Article 440.14 of the National Electrical Code, (ONEC), states that the disconnecting means for air conditioning or refrigerating equipment must disconnect all ungrounded conductors that supply the equipment, including control circuits. Therefore, the Direct Digital Control, or DDC, unit should also be disconnected by the unit disconnect. There are a few options to meet NEC requirements. Firstly, install an auxiliary switch on the 480 volts disconnect that is interlocked with the main switch. When the main disconnect is opened, it will also open the auxiliary switch, disconnecting power to the DDC. Secondly, install a separate disconnect switch downstream of the 480 volts disconnect and in line with the 120 volt circuit for the DDC. This allows for isolation of the DDC control circuit without affecting the operation of the HVAC unit. Using a separate 120 volts circuit without a disconnect is not recommended as it violates the requirement to disconnect all ungrounded conductors for control circuits, as stated in Article 440.14. The best practice is to use either an auxiliary switch with the 480 volts disconnect or a separate disconnect switch for the DDC control circuit. This ensures compliance with NEC requirements and provides for safe maintenance and servicing of the HVAC unit. When selecting an auxiliary switch for the 480 volts disconnect, several factors must be considered to ensure proper functionality and safety. 1. The auxiliary switch must be compatible with the main disconnect switch in terms of voltage, current rating, and physical size. It should be designed to work seamlessly with the existing disconnect mechanism. 2. The auxiliary switch should have a sufficient current rating to handle the load of the 120 volts DDC control circuit. It is crucial to select a switch that can safely carry the maximum current drawn by the control unit. 3. The auxiliary switch must be mechanically interlocked with the main disconnect switch. This ensures that when the main disconnect is opened, the auxiliary switch also opens, cutting off power to the DDC control circuit. The interlock mechanism should be reliable and tamper-proof. 4. The auxiliary switch should be installed in a location that is easily accessible for maintenance and inspection. It should be protected from environmental factors such as moisture and dust. 5. The auxiliary switch must comply with relevant safety standards and certifications such as UL or CSA. This ensures that the switch has been tested and meets the required safety criteria. 6. The wiring connections to the auxiliary switch must be properly sized and installed according to NEC guidelines. The connection should be secure and protected from damage. 7. The auxiliary switch should be clearly labeled to indicate its function and voltage rating. This helps prevent confusion and ensures that maintenance personnel can easily identify the switch. 8. The auxiliary switch should be regularly inspected and tested to ensure that it is functioning correctly. Any signs of wear or damage should be addressed immediately. When selecting a separate disconnect switch for the 120 volts DDC control circuit, several factors must be considered to ensure proper functionality and safety. 1. The disconnect switch must have a voltage rating of at least 120 volts and a current rating that is sufficient to handle the load of the DDC control circuit. It should be sized appropriately for the application. 2. The disconnect switch should be UL listed or have other relevant certifications to ensure that it meets safety standards. This provides assurance that the switch has been tested and is safe to use. 3. The disconnect switch should be installed in a readily accessible location downstream of the 480 volts disconnect. This allows for easy isolation of the DDC control circuit without affecting the operation of the HVAC unit. 4. The disconnect switch should be enclosed in a suitable enclosure that protects it from environmental factors such as moisture, dust, and corrosion. The enclosure should be rated for the intended environment. 5. The wiring connections to the disconnect switch must be properly sized and installed according to NEC guidelines. The connection should be secure and protected from damage. 6. The disconnect switch should be clearly labeled to indicate its function and voltage rating. This helps prevent confusion and ensures that maintenance personnel can easily identify the switch. 7. The disconnect switch should be regularly inspected and tested to ensure that it is functioning correctly. Any signs of wear or damage should be addressed immediately. 8. The disconnect switch should be installed in accordance with all applicable codes and regulations, including the NEC and local building codes. This ensures that the installation is safe and compliant. 9. The disconnect switch should be installed by a qualified electrician who is familiar with HVAC systems and electrical safety practices. This helps ensure that the installation is done correctly and safely. 10. The disconnect switch should be selected based on its durability and reliability. It should be able to withstand the rigors of the HVAC environment and provide years of reliable service. By carefully considering these factors, you can select a separate disconnect switch that is appropriate for the 120 volts DDC control circuit and that meets all applicable safety and code requirements. Remember to consult with a qualified electrician to ensure that the installation is done correctly and safely. Article 440.14 is a crucial section of the NEC that addresses the disconnecting means for air conditioning and refrigeration equipment. This article aims to ensure the safety of personnel who may be working on or around such equipment by requiring a means to disconnect all ungrounded conductors, including those supplying control circuits. The primary purpose of this requirement is to prevent electrical shock hazards during maintenance, repair, or other servicing activities. By disconnecting all ungrounded conductors, the equipment can be effectively de-energized, reducing the risk of accidental contact with live parts. This is particularly important in HVAC systems, where components such as compressors, motors, and control panels may operate at high voltages. Article 440.14 applies to a wide range of air conditioning and refrigeration equipment, including but not limited to central air conditioners, heat pumps, chillers, and refrigeration units. It covers both residential and commercial installations, ensuring that the same safety standards are applied across different types of applications. The disconnecting means required by Article 440.14 must be readily accessible and located in a convenient location near the equipment it serves. This allows personnel to quickly and easily disconnect the power supply in case of an emergency or during routine maintenance. The disconnecting means can be a switch, a circuit breaker, or other approved device that is capable of interrupting the flow of current to the equipment. It must be clearly labeled to indicate its purpose and the equipment it controls. In addition to disconnecting the main power supply, Article 440.14 also requires that the disconnecting means disconnect all ungrounded control circuit conductors. This is to ensure that control circuits, which may operate at low voltages, are also de-energized during servicing. Control circuits can pose a shock hazard even at lower voltages, so it is important to disconnect them as well. The requirement to disconnect all ungrounded conductors, including control circuits, may necessitate the use of additional components such as auxiliary switches or relays. These devices can be used to ensure that all relevant circuits are de-energized when the main disconnecting means is opened. It is important to carefully consider the design and installation of these components to ensure that they function correctly and reliably. Failure to comply with Article 440.14 can result in serious safety hazards and potential violations of electrical codes. It is therefore essential that all HVAC installations are carefully reviewed to ensure compliance with this requirement. This includes verifying that the disconnecting means is properly sized, located, and labeled, and that all ungrounded conductors, including control circuits, are disconnected when the disconnecting means is open. In summary, Article 440.14 is a critical safety requirement that aims to prevent electrical shock hazards during the servicing of air conditioning and refrigeration equipment. By requiring a disconnecting means that disconnects all ungrounded conductors, including control circuits, this article helps to ensure the safety of personnel and the reliable operation of HVAC systems. When installing an auxiliary switch on a 480 volts disconnect for a direct digital control unit, there are several key factors to consider to ensure proper operation and safety. Firstly, it is essential to select an auxiliary switch that is compatible with the existing 480 volts disconnect switch. This includes matching the voltage and current ratings, as well as ensuring that the physical dimensions and mounting options are compatible. The auxiliary switch should be designed to work seamlessly with the disconnect switch, without interfering with its normal operation. Secondly, the auxiliary switch should have a sufficient number of contacts to accommodate the control circuit requirement of the direct digital control unit. Typically, a normally closed contact is used to interrupt the power supply to the direct digital control unit when the disconnect switch is opened. However, depending on the specific application, additional contacts may be needed for other control functions. Thirdly, the auxiliary switch should be mechanically interlocked with the disconnect switch. This ensures that the auxiliary switch is automatically activated whenever the disconnect switch is opened or closed. The interlock mechanism should be robust and reliable, preventing the auxiliary switch from being operated independently of the disconnect switch. Fourthly, the wiring connections to the auxiliary switch should be properly sized and installed according to NEC guidelines. This includes using the correct wire gauge, insulation type, and termination methods. The wiring should be protected from physical damage and environmental factors such as moisture and heat. Fifthly, the auxiliary switch should be clearly labeled to indicate its function and the circuits it controls. This helps prevent confusion and ensures that maintenance personnel can easily identify the switch. The labeling should be durable and resistant to fading or damage. Sixthly, the auxiliary switch should be installed in a location that is readily accessible for maintenance and inspection. This allows technicians to easily access the switch for testing, repair, or replacement. The switch should be protected from unauthorized access or tampering. Seventhly, the auxiliary switch should be regularly inspected and tested to ensure that it is functioning correctly. This includes verifying that the contacts are clean and free from corrosion, and that the interlock mechanism is working properly. Any signs of wear or damage should be addressed promptly. Eighthly, the auxiliary switch should be installed in accordance with all applicable codes and regulations, including the NEC and local building codes. This ensures that the installation is safe and compliant. Ninthly, the auxiliary switch should be installed by a qualified electrician who is familiar with HVAC systems and electrical safety practices. This helps ensure that the installation is done correctly and safely. Tenthly, the auxiliary switch should be selected based on its durability and reliability. It should be able to withstand the rigors of the HVAC environment and provide years of reliable service. By carefully considering these factors, you can ensure that the auxiliary switch is properly installed and functions correctly, providing a safe and reliable means of disconnecting the direct digital control unit when the disconnect switch is opened. When considering a separate disconnect switch for a 120 volts direct digital control unit in an HVAC system, it is important to evaluate the pros and cons compared to using an auxiliary switch on the main 480 volts disconnect. Here are some factors to consider. Firstly, a separate disconnect switch provides independent control over the direct digital control unit power supply. This allows technicians to isolate the direct digital control unit for maintenance or troubleshooting without affecting the operation of the rest of the HVAC system. In contrast, an auxiliary switch and the main disconnect would de-energize the entire HVAC unit, which may not be desirable in all situations. Secondly, a separate disconnect switch can be more convenient to access and operate, especially if the main disconnect is located in a remote or difficult to reach location. This can save time and effort during maintenance and repair activities. Thirdly, a separate disconnect switch can provide an additional layer of safety by allowing technicians to verify that the direct digital control unit is de-energized before working on it. This can help prevent electrical shock hazards and ensure a safe working environment. Fourthly, a separate disconnect switch may be required by local codes or regulations depending on the specific application and location. It is important to check with the local authorities to ensure compliance with all applicable requirements. Fifthly, a separate disconnect switch can add to the overall cost of the installation as it requires additional components and labor. However, this cost may be offset by the benefits of increased convenience, safety, and flexibility. Sixthly, a separate disconnect switch can take up additional space, which may be a concern in some installations. It is important to consider the available space and select a disconnect switch that is appropriately sized for the application. Seventhly, a separate disconnect switch requires additional wiring and conduit, which can add to the complexity of the installation. It is important to ensure that the wiring is properly sized and installed according to NEC guidelines. Eighthly, a separate disconnect switch can be more susceptible to tampering or unauthorized access, especially if it is not properly secured. It is important to take steps to protect the disconnect switch from unauthorized use. Ninthly, a separate disconnect switch requires regular inspection and maintenance to ensure that it is functioning correctly. This includes verifying that the contacts are clean and free from corrosion, and that the switch operates smoothly. Tenthly, a separate disconnect switch can provide a backup power source for the direct digital control unit in the event of a power outage. This can help maintain critical control functions and prevent damage to the HVAC system. By carefully considering these factors, you can determine whether a separate disconnect switch is the right choice for your direct digital control unit installation. It is important to weigh the pros and cons and select the option that best meets your specific needs and requirements. When considering the National Electrical Code requirements for disconnecting means in HVAC systems, it's important to understand the specific articles that apply to different components and situations. Article 440, as previously mentioned, covers air conditioning and refrigerating equipment. However, other articles may also be relevant depending on the specific installation. Article 430 addresses motors, motor circuits, and motor controllers. This article may apply to the motors used in HVAC equipment such as fans, pumps, and compressors. It provides requirements for disconnecting means, overload protection, and short-circuit protection for these motors. Article 480 covers storage batteries. This article may apply if the HVAC system includes a battery backup system for critical control functions. It provides requirements for disconnecting means, overcurrent protection, and ventilation for batteries. Article 620 addresses elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chair lifts. This article may apply if the HVAC system serves an elevator or other similar equipment. It provides requirements for disconnecting means, overcurrent protection, and control circuits for these systems. Article 640 covers audio signal processing, amplification, and reproduction equipment. This article may apply if the HVAC system includes audio equipment for paging or background music. It provides requirements for disconnecting means, overcurrent protection, and grounding for these systems. Article 645 addresses information technology equipment. This article may apply if the HVAC system serves a computer room or other information technology area. It provides requirements for disconnecting means, overcurrent protection, and grounding for these systems. Article 647 covers sensitive electronic equipment. This article may apply if the HVAC system serves an area with sensitive electronic equipment, such as medical imaging equipment or laboratory instruments. It provides requirements for disconnecting means, overcurrent protection, and grounding for these systems. Article 700 addresses emergency systems. This article may apply if the HVAC system is part of an emergency system, such as a smoke control system or a ventilation system for a hospital operating room. It provides requirements for disconnecting means, overcurrent protection, and power sources for these systems. Article 701 covers legally required standby systems. This article may apply if the HVAC system is part of a legally required standby system, such as a ventilation system for hazardous materials storage area. It provides requirements for disconnecting means, overcurrent protection, and power sources for these systems. Article 702 addresses optional standby systems. This article may apply if the HVAC system is part of an optional standby system, such as a backup power system for a data center. It provides requirements for disconnecting means, overcurrent protection, and power sources for these systems. In addition to these specific articles, other general requirements in the NEC may also apply to HVAC systems, such as those related to rounding, bonding, wiring methods, and overcurrent protection. It is important to carefully review the entire NEC to ensure that the HVAC system complies with all applicable requirements. When designing and installing an HVAC system, it is essential to consider the specific requirements of the NEC and other applicable codes and regulations. This includes selecting the appropriate disconnecting means, providing adequate overcurrent protection, and ensuring that the system is properly grounded and bonded. It is also important to coordinate with other trades, such as electrical, mechanical, and plumbing, to ensure that the HVAC system is properly integrated with the building's other systems. The goal is to create a safe, reliable, and efficient HVAC system that meets the needs of the building occupants and complies with all applicable requirements. To ensure compliance with NEC Article 440.14 and other relevant codes, it is important to understand the specific requirements for disconnecting means in HVAC systems. Here are some key considerations. Firstly, the disconnecting means must be readily accessible and located in a convenient location near the equipment it serves. This allows personnel to quickly and easily disconnect the power supply in case of an emergency or during routine maintenance. Secondly, the disconnecting means must be capable of disconnecting all ungrounded conductors that supply the equipment, including control circuits. This ensures that the equipment is completely de-energized, reducing the risk of electrical shock hazards. Thirdly, the disconnecting means must be clearly labeled to indicate its purpose and the equipment it controls. This helps prevent confusion and ensures that maintenance personnel can easily identify the disconnecting means. Fourthly, the disconnecting means must be properly sized and rated for the equipment it serves. This includes considering the voltage, current, and horsepower ratings of the equipment. Fifthly, the disconnecting means must be suitable for the environment in which it is installed. This includes considering factors such as temperature, humidity, and exposure to corrosive substances. Sixthly, the disconnecting means must be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. This helps ensure that the disconnecting means is properly installed and functions correctly. Seventhly, the disconnecting means must be regularly inspected and tested to ensure that it is functioning correctly. This includes verifying that the contacts are clean and free from corrosion, and that the switch operates smoothly. Eighthly, the disconnecting means must be protected from unauthorized access or tampering. This can be achieved by installing the disconnecting means in a locked enclosure or by using a tamper-resistant switch. Ninthly, the disconnecting means must be installed by a qualified electrician who is familiar with HVAC systems and electrical safety practices. This helps ensure that the installation is done correctly and safely. Tenthly, the disconnecting means must be selected based on its durability and reliability. It should be able to withstand the rigors of the HVAC environment and provide years of reliable service. By carefully considering these factors, you can ensure that the disconnecting means in your HVAC system complies with NEC Article 440.14 and other relevant codes. This will help ensure the safety of personnel and the reliable operation of the HVAC system.